whatsoever. So we'll be considering that also briefly before we conclude. So we can talk about data types in different contexts. Uh, Firstly, we could talk about data types in the context of the form in which the data appears. So, how does the data look? What's the form of the data? And when we talk about data types in that context, then we're talking about, uh, you know, if the data is nominal, if the data is ordinal, if the data is discrete, if the data is continuous, right? We're talking about if the data is qualitative or quantitative. Yes, if the data is, so we could, break it into two and say, okay, data could either be qualitative or quantitative. And then if you want to, further break it down, you could then break it into those four categories, right? So you could break it into nominal data, ordinal data, discrete data, and continuous data. So what is nominal data? So there are some kind of data that does not have some kind of any kind of order, right? So data that is categorical and does not have any kind of order, we we call those kind of data nominal data, right? You often classify them or group them based on their attributes, right? So you could say, for example, gender. Gender is an example of nominal data. You can't really, there's no way to order gender, right? And it's categorical. So there's no way to rank, you can't rank gender, you can't rank nationality, you can't rank hair color. All these are, categorical data. You come across nominal data a lot when you collect, the social demographic data of respondents when you are dealing with um, um, survey data. Uh, Apologies that this is not in my slide, but I felt I should first of all mention this before we go into what you can see right there in my slide. So, ordinal data. So ordinal data represents, categorical data that has a clear order, right? So nominal and ordinal are both, categorical data, but the nominal data does not have, an order or ranking, while the ordinal data has a clear order or ranking, right? So you can rank this data and or order them in some kind of way. So excuse me. So when you handle ordinal data, you might see examples like, for example, educational levels, right? So you might be dealing with the if you are dealing with data, patient data or survey data, like I mentioned earlier, social demographic data, in survey data, you might come across educational level. So it makes sense that you can rank educational level, right? So you can rank it. You could start from primary, secondary, tertiary, and so on and so forth, right? So this is an example of ordinal data. So another type of data is discrete data. So this consists of separate values, that you can measure. So you would often represent or see them as whole numbers, right? Uh, Such as, you know, for example, um, age, right? Age is discrete. So you can represent age as a number. So it's an example of this discrete data. And uh, another characteristic of discrete data is you can often find their meaning, right? You can find their mean. You can use summary statistics, on discrete data. You can find their mean, their median, and their mode, right? And you can visualize them in histograms or bar charts, right? So continuous data that is, discrete. Uh, sorry for that. The final type of data is continuous data. So this um, contains information that can assume any value, right, within a range or interval. So you have some data that, they are within a certain range, right? They are within a certain range. You can put them on a scale. You can put them on a scale. So that's continuous data. So you could say, for example, temperature, right? Temperature data can only exist within a certain range. So that's an example of continuous data. So that's in the context of the form of the data. We could also talk about data in the context of programming. And I'm saying this because um, some of the tools some of you might use, or some of the tools that are common in data analysis are, programming tools. For example, R. R is a programming language that was specifically, developed for data science and data analytics. We could also use Python, very, very versatile um, programming language that can be used for data analysis and data science. So when you use, and also JavaScript too, I must mention JavaScript. Uh, there have been, there's a kind of growth in that field, that is in the field, in the application of data science and data analysis for JavaScript. So in the context of programming languages, in the context of programming, data types can exist as integers, often called int, floats, and floats just basically means decimal, right? So you could have integers, you could have floats, you could have string, right? That's just text, plain text. So you could have string, you could have objects, other complex kind of data. So having gotten that out of the way, um, we will now discuss types of data in medical research specifically now. So when we talk about medical research, what are kind of data? And now we are talking in the context of um, the source of the data, right? So not necessarily the form of the data. In any of these types of data, you could find the other types of data we've discussed, So now we are talking in the context of the source of the data. So you could, so we have clinical trial data, survey data, genomic data, electronic health records, right? Imaging and physiological uh, data. This is not an exhaustive list, right? This is not an exhaustive list. There are other types of data you could find in medical research, but these are the very common ones that you could you'd most likely come across. So when we talk about clinical trial data, we're talking about data from studies that evaluate safety and efficacy of medical treatment or interventions, right? So before you could, before they put out a treatment, as a standard, or it must have undergone a lot of clinical trials. So during those clinical trials, you get a lot of data, that would help determine if this treatment is a lot of data that will help you determine if this treatment is safe, if it is effective, and so on and so forth. So, for example, for example, treatment details, patient outcomes, adverse events, demographic information, always important. I think it's it's the first set of data you should gather whenever you are dealing with people. The social demographic information, always very, very important. So that's another example of the kind of data you get from clinical trial data, baseline measurements, follow-up data, etc. So we also have survey data, right? This is kind of data that I personally worked with a lot, or that I personally have worked with the most. rather survey data. You would come across this kind of data a lot if you do public health research, which is what I have majored in. Uh, Public health research, you would usually go out and distribute questionnaires. You distribute questionnaires, collect a lot of data. So the data you get from those questionnaires is what we refer to as survey data, right? Not just questionnaire. It could also be through. It could also be through interviews, right? So data you get from questionnaires, interviews, about patient experiences, behaviors, attitudes, opinions. For example, the during my introduction, you mentioned that I'd worked on a project. One of the projects I'd worked on as a public health research data analyst, um, was the purpose of the project was to assess, right, and evaluate the uptake of the COVID-19 booster dose amongst health workers. And some of the the data points, some of the uh, yes, things we assessed was, their opinions, right, their attitudes, right, the attitudes towards the COVID-19 booster dose. Their there's this word I'm trying to remember now. Pardon me. Anyway, their attitudes, their knowledge, their opinions, and the uptake, of the COVID-19 booster dose. So we try to see, okay, if the attitude, is a determining factor, if their knowledge about the booster dose is a determining factor, if it determines the level of uptake, right, and so on and so forth. So responses to multiple choice questions, these are the kind of things you find in survey data, right? You find responses to multiple choice questions. You find a Likert scale, a Likert scale rating. So, for example, you might want to get someone's opinion concerning, for example, that COVID-19 booster dose, right? So you have a set of questions, and in front of those questions, you have some options. So it could be you want to see if they agree or disagree, right? You just have a statement. It may not necessarily be a question, it could just be a statement. So you try to find out if the respondent agrees, right? So you could have starting from strongly disagree, right? Then then disagree, right? Then indifferent, then agree, then strongly agree. So you can see that kind of forms a spectrum, forms a scale. So we refer to that as a Likert scale. And then we have free text answers. I This personally is one that I don't like. It's very, 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 very cumbersome to deal with, data that comes in form of free text, because of course, a lot of errors at times, and you know it can be very difficult to categorize, right? And it's something you have to do. So it gives more work to the data analyst during the cleaning phase, data preparation phase. They have to do a lot of data cleaning on data like that. So as much as possible, I like to give the respondents options, but of course, you cannot just completely exclude free text answers, because there will be a tendency if you try to regulate the survey, right? If you try to regulate everything, there's a tendency you might lead the respondent on, right? So you want to get to know what they actually think. Right? You want to give them the opportunity to, actually say what they what they think. Right? So you could also um, find out level of satisfaction, and so on and so forth. There's a lot of things you could find from survey data. So those are just very, very few examples. So now we'll talk about genomic data, another data type in context of source. So you could also refer to it as data source for medical research. And genomic data is just, simply put, information about an individual's genes and genetic variations, right? So this one is a bit technical. You may not necessarily, it depends on the area of research you eventually decide to work on, right? But this kind of data is very, very niche. It's not something you come across a lot, right? So it's encompasses information related to an individual's genetic makeup, right? It includes their sequence of their DNA and variations within it, right? So technology has brought us really, really far. Technology has brought us really, really far. So it has enabled us and made it possible to generate vast amount of data from just the genes of individuals. So yeah, that's I won't really go deep into that because it's a bit technical, and this is just an introductory session. So examples of data you could get from you know um, genomic data includes whole genome sequences, right? Genotyping data, single nucleotide polymorphisms, polygenic risk scores, gene activity scores, DNA methylation status. I beg your pardon. DNA methylation status. Right. So I had to read that out because it's not something I've worked with um, at all. I haven't worked on any data analysis project that involves genomic data. All right, moving on, we have electronic health records. A lot of people um, uh, interchange and mistake this for EMR, that's electronic medical records. Although they are very, very similar, they are not entirely the same. They are not the same, right? So we please give me a minute. All right, sorry about that. So we are talking about EHR, right? Electronic health record. So this is the know digital version of patients' medical charts containing a wide range of clinical information. Right. So any term you see electronic in front of, right, it just means a digital version of something that already exists. So electronic health records, just the digital version of patient medical records, right? So example of data you could find from electronic health records include diagnosis, treatment, prescriptions, treatments, prescription medications, laboratory test results, physiologic monitoring data, hospitalization records, administrative and demographic details, insurance information. Right? Those are just some of the examples of kind of data you would find in EHR records. So other types of data, include imaging data. Of course, we are familiar with the MRI scans, CT scans, X-ray scans. These are also quite valuable data, although you work with them in a kind of a different way than you would with the other kinds of data we've talked about. But they are also very, very important data, right, when analyzing or doing medical research. So other examples, physiological data, registry data. This is not an exhaustive list like I've said earlier, right? But that's just some of the data we, we deal with in medical research. Right. So moving on, we're going to talk about some of the statistical concepts. Uh, I hope I don't forget. Well, so as not to forget, I'll just go ahead and say it now. If you want to learn about statistics, right? Because some of these concepts can be quite elusive. They are not very difficult, right? They are not just, there's a tendency for you to forget them. And, of course, some of you might not have used or had any kind of significant contact with some of these concepts rather before now. So, in case you want to learn about statistics, I'll just recommend to you a tutor that I personally have used. Very, 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 very good teacher. His name is Brandon Falls. Brandon Falls. I'll type that in the chat. His name is Brandon Falls. You can find him on YouTube. So he has these lectures, not very long. Well, depends on how in depth you want to go, but he has these courses, a playlist on statistics on YouTube. So you can go there and learn about some of these statistical concepts. He does a very, very good job at explaining them. So that's a resource that I personally have used. So I like to recommend resources that I personally have experience with, right? So it won't just be something that I don't know anything about. So I've used and you know um, um, I've watched his videos, so I can testify to the efficacy of his teaching. So yes, having gotten that out of the way, we'll talk about statistical concepts, right? And first off, we just talk about descriptive statistics. Whenever you come in contact with any kind of data, right, the first thing you want to do is get the descriptive statistics. So, what is descriptive statistics? It's used to summarize and present data in a meaningful way, right? So, example of this is the mean, the mode, the median. Very, very common. I'm mentioning that because something we are all familiar with. So those are examples of descriptive statistics. Excuse me, and they fall under the measures of central tendency. The measures of central tendency. So let me explain what you mean by this. So if you have a certain group, and for example, you are asked to guess the age of anybody in that group. So what's the first thing you try to do? Well, you are not a psychic. There's no way for you to just miraculously know the age of someone that you probably haven't even seen. If you've seen the person, you might, you know, say, okay, using their going by how they look, right? You might want to estimate, but let's assume you can't see this person and you have to guess the age, right? So a reasonable thing to do is to try to get, okay, what is the average age of people in this group, right? What is the average age of people in this group? So let's say, for example, secondary school students, right? So you try to think, okay, this person is a secondary school student. What is the average age of people that are in that level of education? So maybe, for instance, let's say hypothetically, the average age of people in that level of education is 13 or 14. I don't know, but let's just go with that. Bearing that in mind, it's only reasonable that you would, go with that as your guess, right? So I just tried to use that illustration to explain, you know, the the concept of measures of central tendency, right? So without any kind of predictive, tool, without any kind of predictive measure, you would usually go with a measure of central tendency. And we'll come to predictive measures, um, um, soon enough. We'll come to that. So the measures of central tendency, like I mentioned, the median, the mean, the mode, right? I don't think I necessarily have to explain what these mean. Right? I feel this is something that you know we are all we should all be familiar with at this level. But what I would talk about is their peculiarities, their differences. Why would someone go with one, instead of the other, right? If we have mean, why would I need the median, or why would I need the mode, right? So, reason you might need the median, or you might choose to use the median as a measure of central tendencies. The median is not affected, or it is less affected by extreme values, right? It is less affected by extreme values. We call extreme values outliers. So, for example, let's say you have a 100 data sets, right? Um, you have not 100 data sets, right? You have 100 data points in the data set. So, let's say you are dealing with 100 people, the sample size of 100, right? And you look at the age distribution, and you find that, okay, the the ages of people in this group are generally between ages 20 and ages 50, let's say, for example, right? But then in that group you find someone with a that's 98 years old, right? That would be an outlier. So if every other person is within ages 20 and 50, and then there's one person that is 98 years old, that person would be an outlier. And outliers affect the mean, right? Because to get the mean, you add up all the values and divide by the frequency, right? So that outlier would affect the mean, but the median is not affected by outliers, or it is less affected by outliers. So the mode, on the other hand, is the most frequent, you know, in the data set, the most frequent value that you'd find in the data set. So, and it is particularly useful for categorical data, right? So, but it could also be applied to numerical data. Yeah. So, next I would talk about measures of dispersion, right? Talk about measures of dispersion. So, what exactly is measures of dispersion? So, when we deal with data, you generally want to find how how far away, at the data points, how far away are they from the mean. So, we found the mean, we found the mode, we found the median, found the measure of central tendency. But we want to know how far away are the individual data points, how far away are they from the mean, right? So basically it describes the spread of variability. So um, let me explain with the illustration I made earlier. So earlier I was talking about trying to guess the age of you know um, someone in a secondary school, right? So you are trying to guess the age of someone in secondary school. If you go with the mean, right, of course, chances are that you would be wrong. But then you want to know how wrong would you be, right? How wrong would you be? So you chose to make a safe bet, right? You go with the mean because you know that even if the person is older, it won't be too, the age difference wouldn't be too much. And even if the person is younger, the age difference wouldn't be too much. So you choose stand in the middle. But then you want to know, what is that? How would I put this now? Um, how different, right? Or how off would you be? So when we talk about that, we're talking about the measures of dispersion. So it describes the variability, of the data around the central tendency. And um, when we talk about this measure of dispersion, we're talking about variance, we're talking about standard deviation. So how you get variance usually is you get the average squared difference, right, of each value from the mean. So you take each value, you subtract it from the mean. So after subtracting all the values, after subtracting them from the mean, then you get the average, right? And then you square that average, right? So usually this helps to get an absolute value, because when you square a negative value, you get a positive value. Square a positive value, you get a negative value. So this helps to get an absolute value. So that's variance. Standard deviation, on the other hand, is just the square root of the variance, right? And is a more interpretable measure, because imagine if you square, when you square, um, when you get the square, of course, the number will be, a little bit large, depending on what um, you started with. So it may not really make a lot of sense to you at a glance, right? But when you get the square root of that, then it fall, within the range of the values themselves, right? So the standard deviation would, help you get a more interpretable measure, of the typical deviation. So understanding the dispersion of data is very, very crucial. It's very, very important, and the reason is because it provides, insights to consistency, you know, of, for example, treatments, right? Uh, Talked about clinical trial data earlier, right? So you want to measure consistency, right, of results. So measures of dispersion help you get this. Or say, for example, hetero say for example, how heterogeneous a population is, like for the example of the age example I gave, right? You want to know how far is the gap, right, between, how far is the age gap? Are these guys more, um, are the ages, closer, or do you have people who are way older than, or for example, is the oldest person in the group, way older than the youngest person in the group, that kind of thing, right? So that's the importance of the measures of dispersion, right? So we'll be talking about data visualization now, as a fundamental statistical concept. Data visualizations are very, very important. In fact, I don't think your analysis is, if you've not used visualizations, you've not analyzed it, because the analysis would basically be, you know useless to someone other than yourself, right? So if you want to present your data, which I assume is the goal of the analysis, to eventually present your findings, you need to visualize. And even before we even talk about, presenting your data, even for you to understand your data, right? There are things that you would see only through visualizations. Right? There are things you wouldn't see no matter the, statistical method you use. You won't get to see. Some things will not be clear to you unless you go ahead and use, visuals, use a chart or some kind of diagram. They kind of help you bring the data to life, right? And show you, paint a picture of, how, of how the data looks. Yeah, so very, very important data visualizations. Uh, Common examples are histograms, scatter plots, bar charts, box plots. The list goes on and on. Right? There are a lot of examples. Right? So those are just some of the very, very common examples of data visualizations. So let's talk about one of them, for example, the histogram, right? Or um, let's talk about the box plot since it's not something that is very, very common. So the box plot, right, is a graphical summary. We usually use it on numerical variables, right? So it shows the median, the quartiles, and the potential outliers. So what are quartiles? When you segment your values, right, you could categorize them into four. So you have those that fall within the 25%. You have those that fall within the 50%, that's between 25% and the 50%, and those that fall between um, the 50% and the 75%, and then those that fall between 75% and the 100%. So those are quartiles, right? So you see the quartiles in the box plot. You see all the data points that fall within these quartiles, and then you see outliers. Right? Box plots help you to visualize outliers, right? So and then it helps you to visualize the median. So you see the I wish I could. Well, anyway, so that's basically what the box plot is for, and its relevance is that it provides a concise visual representation of the distribution of data. So we've talked about central tendency, we've talked about spread and variation. You see all of that within the box plot. I forgot to time myself, so I don't know how long. Wow, I don't know how much time I have left, but I'll
So
just
you have
as
30 minutes.
30 more minutes.
Yes.
All right, thank you very much. So then I'll just take notes of that. I would like to time myself. Give me a minute so that I don't. All right. Yeah. So we were talking about um, data visualizations. All right. I would like to move on to sensitivity and specificity. So this is an essential for evaluating diagnostic tests, right? Sensitivity measures true positive, while specificity measures true negative. So this can be a little bit, you know, um, confusing if I try to, you explain all this, but I'll try. I'll try. So the the positive predictive value, there's something we call PPV, right? The positive predictive value is the probability that an individual actually has a condition. So for example, we are trying to see the the probability that an individual has a condition or does not have a condition based on some kind of data, right? We gather some kind of data. We are trying to see, okay, based on this data, what is the probability that an individual possesses a certain type of condition, right? So the positive predictive value is the probability that an individual actually has the condition given a positive test result. That's considering the data, right? And then the negative predictive value, that's the NPV, is the probability that an individual does not have the condition, given a negative test result, right? So that's why we say, specificity is about true negative rate and sensitivity is about true positive. Well, I just hope. Well, this is an introduction, so this is just meant to introduce some of these concepts, not necessarily make you understand them fully. So just knowing that some of these things exist, right, is enough. So with more contact, and I would like to just say this, right. So the best way to learn generally have come to realize that the best way to learn, and you know, this stands true, especially in technical skills in tech, stands very, very true. Best way to learn is to do. I remember when I started out, as a data analyst, I started with Excel, right? So I learned Excel formulas, how to manipulate data in Excel. Excel is very, very powerful, by the way. I don't know. A lot of people don't see how powerful Excel is. Excel is very, very powerful. Most of the statistical tests and methods we carry out in other tools, you could do them in Excel. Excel can do a lot. There's a lot you could do with Excel if you could just learn it. So and with the way technology has advanced, with all the AI models we have today, right? A lot of things have been made very, very easy. In fact, you could just ask an LLM to tell you, the formula you would need, or how to carry out a particular statistical test in Excel, and it will tell you. So I digress. I started out with Excel, and then when I would work on my first project, I had to use um, some tools that were completely new to me. And I had to use Starter. I don't know if I'm pronouncing it well. I don't know if it's Starter or Stata, right? So, but I had to use Starter. I had to use a data collection tool. It's called Copo Toolbox. So I had to use these tools, and I basically didn't know how to use them. So I had to learn how to use them. And what helped me, um, internalize, the skill and the expertise in these tools very fast, was the fact that as I was learning, I was using it on something real. I was working on a real project as I was learning to use those tools. Right. So the best way to learn is to do. So I would really advise, if you are serious, and data analysis is not really a niche skill anymore. I think it's something that is um, a necessary prerequisite if you want to do any kind of research. You don't have to say, okay, data analysis. I'll get someone who is a data analyst to carry out. Even if someone else is doing it, you still need that understanding. You still need to be able to understand. Okay, you have the results in front of you. You still need to be able to understand it. So I think it's a minimum requirement in today's world, right? For people in a lot of diverse fields, most especially the medical field, to have this skill and understanding of these um, concepts. So I would advise that you try to work um, data data sets. You go online, there are a lot of data sets. I'll share some sources with you guys immediately after the session, where you could find data sets, most especially medical data, and kind of work on this data using some of the things or some of the concepts or some of the methods we've talked about. Right, that would really help and go a long way in helping you with analyzing these concepts. So yeah, we just talked about um, specificity and sensitivity. Right. So and I've also talked about predictive values in conjunction with that. So move on to inferential statistics. Right. We're moving on to inferential statistical methods. So inferential statistics extends beyond descriptive statistics, right? Descriptive statistics just helps you get a feel for the data and helps you get a general outlook, a general overview of the data, right? So you want to dig deep, you know, um, 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 you know, go into inferential statistics. These allow researchers to make generalizations about the larger population based on sample data, right? This includes techniques like hypothesis testing. And um, when you want to test hypothesis, you generally have, two um, hypotheses. Right? You have the null hypothesis, you know, and then you have the alternative hypothesis. The null hypothesis is usually the unbiased, hypothesis, the hypothesis that what you are testing for, right? The hypothesis, the assumption rather that it is not true. The assumption that it is not true. Say, for example, we gather a group of people, right, and want to see if, let's say, okay, something very, very easy to understand, right? Let's say we want to see if the um, incidence of um, uh, diabetes, or no, let me use something, arthritis, right? Let's say it increases with age, right? The tendency that the person will have arthritis, let's say it increases with age, right? We want to find out if that is true. So the null hypothesis would be that that is not true, right? So straight, that's I think that's simple enough. And then the um, alternative hypothesis would be that it is true, right? So your entire research would be centered around this hypothesis testing, and at the end of the the research and the data analysis, you would eventually have to make a decision, and decide whether you would accept or reject you know your hypothesis, right? And to make this decision, you need something known as a p-value. You would do some statistical testing, right? That's the third concept. So you will do some statistical testing. There are different types of statistical testing you carry out on your data. You could carry out t-test. You carry out chi-square test. That's number four. You carry out ANOVA, depending on the kind of data you are working with. So after you've carried out this test, you would usually end up with a value that lets you know, right? Lets you know how close your hypothesis is to the truth, right? So usually, for your test to be statistically significant, you need a p-value that is less than 0.05. The closer your p-value is to the closer it is to zero, the better, right? The closer it is to zero, the better. So you want a p-value that is very, very close to zero, right? So, but there's a benchmark, right? There's a benchmark. There's also level of confidence. I wouldn't really go into that, but level of confidence just refers to, okay, now we've exceeded the benchmark, but how close are we to zero, right? So you usually set certain level of confidence, and you know I remember when I did my undergraduate thesis, I represented it with stars. I think very, very common to represent it with stars. So just as when you leave reviews, right? You see 3 stars, you see 4 stars, you see 5 stars. So you would also do that with your level of confidence. Yeah. So the different kind of tests you could carry out. You have the t-test, you have the chi-square test. I'll try to be quick. I don't have a lot of time left. So you have the um, correlation analysis, the ANOVA analysis of variance. Remember, we talked about variance earlier. So you further analyze the variance, and then we have regression analysis. Let me just talk about correlation analysis, right? So I remember when I was in secondary school, I think this is something we all should be familiar with, right? Should be familiar with proportionality. Remember then when we used to cram the all the Boyle's law and the Charles law and the Avogadro's law and so on and so forth. You know, I just remember that something was always proportional to something, right? And I remember then all we just did was memorize. We didn't really, try to understand or weren't given the opportunity to understand. So, but I want to believe we all know what proportional means, right? So, something that is either directly proportional or inversely proportional. So, when two things are directly proportional, it just basically means that when one increases, the other increases too, right? So, for example, the more I'm trying to use a very I don't know when something is too common, right? It becomes difficult to get an example, right? So, well, anyways, when something increases, another increases. So you are considering two variables, right? A dependent and an independent variable. So when one increases, the other increases. If they are inversely proportional, just think.
Mr. Charis, looks like he's having a little bit of network issue.
Sorry about that. But I
All
don't
right.
know why my internet suddenly, my Wi-Fi just suddenly stopped working. So I had to very quickly switch to mobile data. So if I could just share my screen again. All right, please confirm if you can see my screen.
You can see your screen, sir.
All right, thank you very much. So I don't know exactly where I got cut off, but I remember I was talking something being directly proportional and inversely proportional, and I was relating that to positive and negative correlation. So when you correlate two values, right, you try to see if there is a basic. First of all, what is correlation? So correlation is if two values are related, right? If they are proportional, like I said, right? So if as one increases, the other increase. And please let's not mistake this for causation, right? I just feel I have to very quickly say that. So correlation is different from causation. A lot of people mistake two. So just because two values are related in that they increase together or decrease together does not mean one is responsible for the other, right? Does not necessarily mean one is responsible for the in the other. So let's say we are trying to test correlation between two values, right? The correlation coefficient is the result of this test, and it is usually between -1 and +1. So the value will fall between these two. It will not go beyond those two. So the closer it is to -1, the more it indicates a strong negative, right? That's what we refer to as inverse proportionality, right? And the more closer it is to the positive value of one, then the stronger the correlation is. The positive correlation is. So, for example, let's say we are investigating relationship between body mass index, that's the BMI, and systolic blood pressure, right? So this is an example of where you would do a correlation um, analysis. So for chi-square tests, you are analyzing categorical data, and you are assessing associations, right, between these categorical data. Let me just look at. I have just 10 minutes left. So yeah, regression analysis is very very similar to correlation. So it models the relationship between independent and independent variable, right? So you are predicting now, right? So that's the use of regression analysis. For correlation, you are just seeing if they are related, if there is a positive correlation or negative, if there is a correlation, right? If there is a proportionality, right? But for regression now, you are predicting. So you are predicting one value using the other. Right? So for example, let's say you are predicting the likelihood of readmission based on patient's demographics, right? Or medical history or discharge medications, right? So you are trying to predict what is the likelihood that this patient would be readmitted based on their demographic data. Right? So that's an example of an instance where you would use regression analysis. So there is linear regression, there's logistic regression. Linear regression is when you are using continuous data, you are using numerical data, right? Logistic regression is a classification model. So basically, um, you are dealing with categorical data. So I think I'm almost at the end of my slides. So yeah, so let's move on to the tools, the essential data analysis, and I'll be talking about some free resources you could use to learn. Let me just say this: YouTube is your friend, right? If you want to learn anything whatsoever, I think you could. All right, I thought my network. I thought I lost connection. So there is I'll try to leave some links to some people, some channels like on YouTube that would really help. There's also free code camp, right? But if you are talking about data analysis that is specific to medical research, then you can find that on Coursera. Right? I think Stanford University has some very very unique courses, right? So you can find that on Coursera. I also try to leave some links, right? So yes, let's dive into the tools. I mentioned R earlier, right? So R is a programming language. It was specifically designed for data analysis and data science. Excuse me. Python is a powerful library. Now, a lot of people usually have this question: which should I learn, R or Python? I'm not taking sides, but I would, just very simply advise you to learn Python. The reason being that Python is more versatile. Anything you can do with R, you can do with Python, basically, right? And Python has a very, very large online community, right? There's very, very, very large support. There are a lot of packages out there. There are a lot of packages for R, right? Online too. There are a lot of packages have been created, a lot of libraries out there for R, and R even has an R studio, right? It's a software that is tailored um, for analysis and visualizations. Very very powerful. Um, but I would still advise you learn Python because Python is just more versatile. There's much more you can do with Python, and just having that basic knowledge of Python would help you a lot, right? And it's easier to learn R if you've learned Python. So if for any reason you still have to learn R, you can you find it very easy to learn um, R if you already know Python. So there are a lot of libraries, Python libraries like NumPy, Pandas. Once again, if you need to learn any to use any of these libraries, YouTube is your friend. SciPy. When you're talking about statistical modeling, that's machine learning, then you use libraries like PyTorch, scikit-learn, um, and the likes. So there's MATLAB, right? Although I don't mention that in my slide, right? But there's MATLAB. There are a lot of tools, right? More common ones are SPSS, right? SAS data, but there are a lot of tools. So um, in academic research, right, you find SPSS, SAS data. These ones are the most common, right? Especially in this part of the world. You don't find a lot of academic work where they use Python, or R, right? So, but the issue is software packages like SPSS data. They are commercial software, right? So you may need to pay. You may need to buy a license to use these software, right? So a very brief summary of what we've gone through today. We've talked about statistical methods. We've talked about descriptive statistics. We talked about comparative analysis. Although I didn't really go deep into some of those statistical tests, like the T test, I didn't really, because of time, I didn't really explain. But I created a guide, right? I wrote, I wouldn't call it a book, but it's a guide. It's not too long. I think it's um, under 20 pages, right? So I created a guide. It was this, research module that inspired me to create that guide. And most of what I've been saying, you would notice that sometimes um, I've been reading something out. So I've been reading some of the things I've been saying out from my guide. Right. So I'll try to also make that available. Right. I'll try to make that available and get it across to you guys. So it contains everything we've gone, we've talked about today can be found in that guide. Yes, an introduction to um, data analysis for medical research. So I'll try to convert it and make it into an ebook and get it across to you guys. So um, sorry if I've not been able to elucidate some of these concepts properly, but I'm sure you know um, find you'll be able to reference everything we talked about, you know, in the guide. So we've talked about chi-square test. We've talked about exploring. We've explored correlation analysis. We've talked about regression analysis, and we've talked about um, logistic regression. So regression and logistic regression, they are basically regression analysis. That's linear regression is for um, numerical data, and then logistic regression is for classification, right? So and then um, we've talked about a lot, right? And I feel there's so much more that have been excluded, from this session because, of course, it's just an introductory session, right? It's just an introduction, and I tried not to get too technical, just to kind of give you a first exposure, first contact with some of these concepts. I don't know what the level of expertise is, you know, but since you are all still students, so I would assume that you haven't really had any substantial contact with some of these concepts. So I tried not to get technical especially when it comes to the tools, right? So once you know these concepts, especially the statistical tests. There are a lot of calculations, but these tools, kind of give you an abstraction. You don't really need to learn those calculations. You don't really need to learn the calculations behind logistic regression, correlation analysis, and all that, because you could just get your values with the click of a button. So, where the learning curve might be would be learning to use these tools, right? So, once you understand the concept, what you would need to learn is how to use those tools. And, like I've said earlier, you would, you know, find great help in YouTube. I don't believe that there's any of these tools you would want to learn that you won't find a playlist somewhere, multiple playlists, right, on YouTube. So, um, ethical considerations. Wow, I thought that was my last slide. Um, Ethical considerations. Of course, you would want to be careful when you use um, people's data. These are real people, these are human beings. So you want to ensure confidentiality. I don't think this is something that will be new to you guys, being that you are in the medical profession, but you want to ensure confidentiality and anonymity. A lot of data sets you find online, won't really give you specifics about the individuals, where that's where the sources of the data. So that's due to data privacy. So informed consent is also required before you use anybody's data for any kind of research. You need to get their consent, right? You need to get before hospitals can give out data. Data is like, there's a saying that data is the new gold, right? Especially in this part of the world where there's a high deficiency of data, right? And there are companies, I can tell you, there are companies whose profit model is centered around selling data. There are companies that just sell data, and that's why you find a lot of scandals with big tech companies like Facebook and the likes, and all those scandals like TikTok and all those scandals are usually centered around data. So you need consent of individuals before you carry out any kind of research on their data, right? So you should also avoid bias, right? And you should be transparent, right? You should be transparent about the methods. That's why the methodology section of any research paper is very, very important. Even um, what's it called now? Review, right? Even paper reviews where you are not actually the one doing the research, you still need to have some kind of methodology, right, for transparency, because whatever you do has to be reproducible. What that means is that someone should be able to go through the steps you outlined, right, and arrive at the same results, right? So that's what it means. So yeah, you need to be transparent. So those are just some of the ethical considerations when it comes to. Sir? No, no, no. All right. So yeah, we have come to the end of the session. Thank you very, very much for your attention, um, and thank you for the opportunity to speak. So, like I've said, I would, you know, welcome any questions. Right? I should have left. Oh, I'm really, really sorry. I should have left some, a few minutes at least for questions or not. But at this point, I've already exceeded, the allotted time. So, but anyway,
So we
my
have a few minutes for questions.
all right, all right. That's wonderful. That's wonderful. So, yeah, I think
If you have any questions, just five.
so.
Or if you don't want to speak, you can put it in the chat box, then I'll read it out.
Yeah, also, and for anyone that might have, any questions beyond beyond now, right? My contact is always open. right? I'm always open to send me your questions on WhatsApp.
So does anyone have any questions? Hmm. Does anyone have any questions? Okay, someone asked, please, what is the name of the YouTube tutor you recommended for us on statistical concepts? Okay, Mr. Charis has responded. It is Brandon Holt. Thank you. Are there any more questions? Okay. We would like to get the slides to sir. Will that be possible? Mr. Charis. Someone is asking if it would be possible for us to get the
Yes,
slides.
yes, I was trying to unmute myself. Yeah,
All right.
I would make not just the slides, but the guide, which is the source material for the slides. Like I said earlier, I think that would even be better. There isn't much, in the slides, so the guide would be more helpful to you. So I'll try to convert that, into an ebook, like I said earlier, and make that available.
All right. Thank you very much. Someone is asking, please, sir, could you explain free text again?
All right, so I would, you know, I like to think you are referring to when I was explaining data sources, right? And specifically when I was talking about survey data. So when you know try to gather survey data, right? Survey data is the data you get from questionnaires, right, and interviews sometimes. So these questionnaires, they are usually multiple choice questions, meaning the answer is there, right? It's not an exam, right? But you provide options. This makes it very, very easy for you to analyze data when you give the respondents options, and it makes it easy for them to answer your questions and fill the questionnaires, right? They don't. It means they don't have to think, do a lot of thinking, to answer your questions. So, but free text is when you give them, the opportunity to give an answer, right? That's not a multiple choice. That's when you ask a question that's not multiple choice, right? So for example, when you give options and then you provide order, right, as an option. So maybe the answer is not in the option. Some of these questions you can't really exhaust all the options, so you give the most common options and then you write order, and then if they select order, you ask them to specify. So when they specify, that's an example of free text. And another example could be when the question itself is not even a multiple choice question from the get go. It's just a question where you ask them to kind of just provide whatever it is they think, right? So that's what I mean by free text.
Okay. think you have answered her question. All right. So, in the absence of any questions, we have come to the end of today's session. Thank you again, Mr. Charis, for taking out your time to explain to us in a certain level of details data analysis and research. Really appreciate it. Thank you very much. Also, I would like
You're welcome.
Thank you. I'd like to appreciate every single one that joined this meeting from the beginning to the end. I am sure you got value for your time, and thank you guys once again. That will be the end of today's session.